welcome to this lesson. We continue with the topic sequence and series, and this time around we are going to do geometric sequence or geometric progression. So again, we are going to at least define what geometric sequence is, because it is very much important to know what this kind of a sequence is. Now, it is a sequence. Geometric progression or geometric sequence is a sequence with a common ratio, and the ratio of any term to the previous term must be constant. And therefore, we also have the nth term of this sequence, and the nth term includes the first term and the common ratio, which in this lesson we are going to see how it is derived. Now, just to start, tell whether the sequence is geometric. So part A, we have part A and part B. The sequence in part A is 4, 10, 18, 28, and 40. And remember, the sequence continues. So we need to work it out so that we are getting the common ratio, which is going. Remember, the common ratio should be constant. That is what will tell if it is a geometric sequence or not. So if the common ratio is constant, then it is a geometric sequence. If it is not, then it is not a geometric sequence. So to decide whether a sequence is geometric, find the ratio of the consecutive term. So we have 10 over 4, that will give us 5 over 2 upon simplification. Then we also have another one is 18 over 10, that is 9 over 5. So we cannot even continue because the ratio is not the same, it is not constant. So, and we expect the ratio to be constant for it to be a geometric progression. So even if you continue, you still find a ratio that is not common. So we can try part B. So you find out that before part B we have the ratio are different, so the sequence is not geometric. Part B, we have the sequence starting with 625, 125, 25, 5, then 1, and it continues. So to find the common ratio there, we have 125 over 625, which will get 1 over 5. Again, next one is 25 over 125, it is 1 over 5. The other one is 5 over 25, which is 1 over 5. And lastly, 1 over 5, which is still 1 over 5. So here you realize that the ratios are common or constant. Therefore, the sequence is geometric. The sequence is geometric because of that. Now, on a different concern, tell whether the sequence is geometric, and if it is so, explain. So the sequence here is 81, 27, 9, 3, and 1, and it continues. And so if you get the common ratio, it will be 27 over 81, that will give you 1 over 3. 9 over 27, again it is 1 over 3. 3 over 9, 1 over 3, and so on. So that means that sequence is geometric. Number 2, we have 1, 2, 6, 24, 120, and it continues. So that means if we try to get the common ratio, it will be 2 over 1, then 6 over 2, that is 3, meaning they are not the same. 24 over 6, that is 4, and 120 over 6. So you realize that the ratios here are different. So the sequence is not geometric. If we go for the third one, the sequence is -4, 8, -16, 32, -64, and it continues. So we find out that you get the ratio, the common ratio, to be constant, that is -2. So the sequence is geometric. The sequence is geometric in this case. Now let's now do something on the nth term of a geometric sequence. We want to find how do we get the nth term of a geometric sequence. Like what I said, the nth term here, it constitutes the first term and the common ratio. So write a rule for the nth term of the sequence, then find the seventh term. Find out the seventh term. So we start with part A, 4. We have a sequence of 4, 20, 100, 500, and it continues. So we start with finding, of course, the first term here is 4. Our first term is 4 in this sequence, and the common ratio will be 5. So that is 20 over 4, that is 5, and it should be common. Maybe you can just prove if it is common. 100 over 5 over 20, that is still 5. 500 over 100, it is 5. So it is a common ratio. So the rule for the nth term is, the general form is AR raised to n minus 1. That is the general format of the nth term of a geometric progression. So with that, we'll be doing substitution. That is a into 5 raised to power n minus 1. So the seventh term, of course, that is the nth term. So now if you want the seventh term, then of course it will be AR raised to power 6. Because n there is 7, so it will be 7 minus 1, which gives you 6. So for the seventh term, it will be AR raised to power 6. And so what we do here to get the seventh term, we just substitute n with 7 from the nth term, and now our answer is 62,500. That is part A. On part B, the sequence is geometric with the first term 152, and the common ratio is -75 over 152, and that is -1/2. And you need to prove if it's common all through the sequence. It's very important. So the general rule for the nth term of a geometric sequence is AR raised to n minus 1. And now that we have the value of A and R, we substitute straight away so that we come up with the nth term. So we have 152 into 1/2 raised to power n minus 2 minus 1, that being the nth term. Then we are asked about the seventh term. So where there is n, we substitute with 7. And now our seventh term is 19 over 8. So on another example, the fourth term, now we want to find out the nth term given a term and a common ratio. So the fourth term of a geometric sequence is 12. And the common ratio is 2. So on part A, write a rule for the nth term. So being given the fourth term to be equal to 12, that means we are going to write the fourth term with respect to the first term and the common ratio. With the first term and the common ratio. So that means it will be, when we go back to the nth term, we have AR raised to power n minus 1, and our n here is 4, so that will make it easy to come up with the fourth term. So with the fourth term, it will be AR raised to 4 minus 1, and that will be AR raised to power 3, or rather AR cubed. But the fourth term, we were told it is 12. So that means we are going to substitute so that we find the unknown. And the unknown here is a. So that will give us the value of a, that is the first term, to be 1.5 or 3/2. Now with this, we can now substitute in the expression for the nth term so that we get the rule for the nth term with concerning, or rather regarding to this question. So we have the first term to be 1.5, and then our ratio was 2, and so that will be the nth term. This is our nth term. So let's move to this other question where we are going to write the rule given the two terms. We are writing the rule given the two terms of a sequence. Two terms, and the question is two terms of a geometric sequence are, we have the third term is equal to -48, and the sixth term is equal to 3072. Now find a rule for the nth term, or rather write down the nth term. So with that, of course, depending on the nature of our question, we are going to have two equations. We're going to have two equations, after which we will solve using either substitution method or elimination to just find the value of the unknowns. Then we come back and substitute the value of the first term and the ratio in the nth term. So we start with step 1. We write a system of equation using the nth term and substituting when n is equal to 3 as the first equation and n is equal to 6 as the second equation. So just to start, we have ar raised to power 3 minus 1, and remember the third term was given to be -48, so it will be -48 ar squared. On the second equation, we have 3072, that is 3072, is equal to ar raised to power 5 because it was the sixth term. So we have the two equations. We just need to solve them. Remember, these are simultaneous, but we are not going to use the, okay, we can use any method, either substitution, but with elimination here maybe it can't work. So we can use substitution, where the first one we make a to be the subject of the formula. So we have a is equal to -48 over r squared, and then equation 2, we substitute what we have in equation 1, the value of a in equation 2. So we will have 3072 is equal to -48 over r squared, which is standing in place of a, then multiply by r raised to power 5. So with that we can simplify, and then we'll get 3072 is equal to -48 r cubed. Now it is easy to get the value of r by cube rooting both sides, and that will give us the value of r to be -4. The value of r is -4. So to get the value of a now that we have the value of r, we substitute in -48 over r squared is equal to a, so that we get the value of a. So we will have -48 is equal to a into -4 square, and that will give us a to be -3. So with that information, we can now write down the nth term, which now is, we have -3, that is the a, that is the first term, into r, that is -4 raised to n minus 1. So this is our nth term. Let's do one more question. Write a rule for the nth term of the geometric sequence then find the eighth term. So if you look at this pattern, we have 3, 15, 75 and 375. We are looking for the eighth term after writing down the nth term. So the first term of this pattern, or rather sequence, is 3, and the common ratio is 5. The common ratio is 5. So that means for the eighth term, the answer will be 234,375. So that is the eighth term if you work it out. But the nth term will be 3 into 5. Of course, 5 is the value of r. 3 is the first term. And then into raised to power n minus 1. Of course, for the eighth term where there is n, you substitute with 8. Then you'll get that answer there. You can also try this one. We have the sixth term, the eighth term. We are told about the sixth term to be, okay, this one is on a different part. So we have the ratio to be 2 and the sixth term to be negative 96. So with that information, you can work it out to find the eighth term, because that will just help you to find the nth term, the first term, and then substitute to find the sixth term, the eighth term I mean. You can also try number 6. Answers are provided just to see if you are correct. So thank you viewers for watching this lesson. Subscribe and share with your friends.